Hello everyone, this is Dr. Bharat Vinjamuri from Department of Mechanical Engineering, Global Academy of Technology, Bangalore. In today's video session, we'll be discussing about the gas welding process. Also, we'll be discussing about the different types of gas welding process like Oxy-Acetylene gas welding process. The different types of flames during the process like neutral flame, carbonizing flame and oxidizing flame will be discussed in this session. Also, the different types of gas welding process like Oxy Hydrogen Welding process, air-acetylene welding process will be discussed in detail. At the end of the session, we'll be discussing about the different types of gas cutting process like Oxy-Acetylene gas cutting as well as powder cutting process. Metals can be joined in many different ways. Gas welding is one of the most important ones because of its scope of application. It is the oldest form of heat-based welding and is widely used in many industries. Gas welding is the process of joining metals using the heat transmitted from the flames. Carrying out a welding process with gas welding is relatively easy and does not necessarily require expert welders. Gas welding is all about heating the ends of the materials to a point that they melt and fuse. To achieve this, the welder must have a piece of equipment that can create high temperature flames. Gas welding uses the combination of oxygen and highly flammable gas. Most commonly, oxygen is mixed with gases like acetylene, hydrogen, propylene and butane. The most commonly used gas welding fuel is acetylene. It is so popular that many replace the term gas welding with Oxy-Acetylene welding. Let us now understand the principle and working of Oxy-Acetylene welding. In this process, the acetylene and oxygen are mixed in correct proportions in the welding torch. The chemical reaction between oxygen and acetylene takes place in two stages. At stage 1, oxygen and acetylene react to produce carbon monoxide and hydrogen. This reaction occurs at the tip of the torch. The byproducts of this reaction combine with the oxygen in the atmosphere, thus producing enormous amount of heat. At stage 1, acetylene react with oxygen to form carbon monoxide and hydrogen, liberating heat at the tip of the torch. The byproducts of stage 1 will react with the oxygen present in the surrounding air. This secondary reaction takes place at the outer envelope. Almost 2/3 of the total heat is produced at stage 1 and 1/3 of the total heat is produced at stage 2. Gas welding requires a system where two gases, oxygen and fuel, can be safely mixed and burned together. It also requires a mechanism for the welder to control the flames. To satisfy all these conditions, gas welding equipment must consist of acetylene cylinder or the fuel cylinder, the oxygen cylinder, control valves, mixer chamber and welding torch. Let us discuss in detail about various equipments in Oxy-Acetylene welding process. The cylinders used to hold the gas are shown in the diagram. The black color one is usually the oxygen cylinder and the red color one is acetylene cylinder. This fuel cylinder holds the fuel required for combustion and the oxygen cylinder holds the compressed oxygen required for the weld. Both the oxygen and the fuel cylinders are made from heavy steel to withstand the pressure. Both the gases have separate control valves. A control valve is used to control the amount of gas being released from the cylinder. Control valves also are crucial for controlling fuel to oxygen ratio. A welding torch contains a mixing chamber. A mixing chamber is a housing in which the acetylene and oxygen mix together. The control valves are used to regulate the flow of gases from the cylinder to the mixing chamber. At the other end of the torch, a nozzle is provided where the fuel and the oxygen mixture burn together. Let us now discuss the operation of welding process. Initially, the metals to be joined must be cleaned. A suitable flux is applied over the joint if necessary. The acetylene valve is opened gradually and the torch is ignited. Oxygen valve is then opened slowly. Oxygen starts mixing with acetylene at the mixing chamber of the torch and starts burning at the tip of the torch. Based on the type of metal and the thickness of the metals to be welded, a suitable flame has to be obtained. Later, the filler rod coated with the flux is melted and is used to fill the gap at the joint. Both the torch and the filler metal has to be moved together over the joint. The flame is switched off by closing the valves. The joined metal pieces are then allowed to cool and then cleaned. Certain key features of gas welding make it so popular in the field. We will discuss some of them here. One of the greatest strengths of gas welding is that it can weld non-ferrous and ferrous metals together. When we compare gas welding to other popular weld methods like arc welding, gas welding does not require any electricity to operate. Hence, we can use gas welding in the places that do not have access to electricity. The initial capital for gas welding is very low as it does not require specialized machinery. Gas welding does not require highly specialized labor. This makes it easier to find gas welders as well as keeps the labor charge low. The whole setup for gas welding is easily portable. There are few disadvantages in this process. This welding may not be suitable for thick sections, and the process cannot be used for high strength steel because of limited temperature ranges. The process is slow due to slow rate of heating, and also the temperatures cannot reach the temperatures of arc welding process. This process does not have a dedicated flux shielding system. Gas welding is used in a variety of industries. Here is a list of some of the most common applications of gas welding. One of the most common applications of gas welding is for repair works. Thin to medium sheet metals are easily welded using this process. This process is used to join various aircraft parts. It is used to weld the parts of the frame and the chassis in an automobile. Gas welding is very effective in melting high carbon steels. Thus, gas welding is one of the many weld methods that we use today. The low cost and easy availability of the labor makes the gas welding one among the most popular weld methods. Let us now discuss the different types of flames produced during Oxy-Acetylene process. Basically, there are three types of flames that are produced by varying the proportions of oxygen and acetylene: neutral flame, reducing flame, as well as oxidizing flame. Let us discuss the applications of each flame. To produce a neutral flame, open the acetylene valve initially and ignite with a lighter. The acetylene flame is pale yellow inside and deep yellow color surrounding it, and it is smoky at the outer tip of the flame. Open the acetylene valve slowly until the smoke at the tip of the flame reduces. Once the smoke has been reduced, now you can open the oxygen valve in the torch slowly and notice that there is a bright flame that settles in a different color. Now you can see a small greenish color cone from inside. As you slowly increase the flow of oxygen, the inner cone will slowly lose its blurred edges. Notice the pointed, smooth inner cone surrounded by the second bluish luminous cone. Also, a sharp purring sound can be heard, telling you that a neutral flame is correctly adjusted. In this case, the volume of oxygen and acetylene will be the same. The tip of the inner cone is the hottest part of the flame, reaching a temperature of approximately 6300 degrees Fahrenheit or 3400 degrees Celsius. A neutral flame can be used to weld all the metals, including cast iron, malleable iron, wrought iron, and high-strength steels. Another type of flame used in welding is carbonizing or reducing flame. This flame is produced with more amount of acetylene and less amount of oxygen. To produce the carbonizing flame, open the acetylene valve initially and ignite the acetylene with the lighter. Adjust the acetylene valve to produce smokeless acetylene flame. Once the smoke is reduced, open the oxygen valve slowly. As you increase the oxygen, the acetylene flame will turn into purple color and the greenish color inner cone starts to form. When intermediate cone stays like a feather, then stop adding oxygen. A properly adjusted carbonizing flame will have 3 flame zones: white inner cone, an intermediate feather, and a bluish colored outer envelope. The intermediate cone will be about twice the length of the inner cone. The temperature of the inner cone will be around 5700 degrees Fahrenheit or 3100 degrees Celsius. Thus, a carbonizing flame will have 3 inner cones: a sharper inner cone, intermediate acetylene feather, and a bluish outer envelope. The third flame used in Oxy-Acetylene welding is the oxidizing flame. This flame is produced with more amount of oxygen than acetylene. To produce the oxidizing flame, the process is same as discussed earlier. Open the acetylene valve and ignite the acetylene. Adjust the acetylene valve to produce smokeless acetylene flame. Now open the oxygen valve slowly to get a neutral flame. Later, slowly increase the quantity of oxygen so that the inner cone of the flame becomes much sharper and smaller than the neutral flame. At this point, there will be a hissing sound indicating the presence of oxidizing flame. The oxidizing flame is the least used compared to the 3 types of welding due to its oxide formations. The use of oxygen and hydrogen as the gases for welding and cutting is older than Oxy-Acetylene process and dates back before the production of oxygen. Oxygen Hydrogen Welding uses a mixture of hydrogen and oxygen for producing gas welding flame. The temperature of the flame will be around 2500 degrees Celsius. The temperature of the flame can be varied by varying the oxygen supply. The flame thus obtained was used for cutting and welding thin sheets and low melting point alloys like aluminum, magnesium, lead, etc. The apparatus required for Oxy Hydrogen Welding is similar to Oxy-Acetylene welding and consists of primarily two steel cylinders for oxygen and hydrogen along with a welding torch with a mixing chamber. In operation, suitable mixtures of hydrogen and oxygen are individually supplied and combined in the mixing chamber. Theoretically, complete combustion requires a hydrogen to oxygen ratio of 2:1. When the mixture is ignited at the torch tip, combustion takes place, resulting in a flame having a temperature around 2500 degrees Celsius. The burning of hydrogen and oxygen results in two byproducts, water and heat. The combustion equation is as follows. Air-acetylene setups offer a better and more economical alternative to brazing and soldering. There are certain drawbacks using Oxy-Acetylene welding process. For example, it has much bigger and heavier torch. It has two tanks instead of one to carry around, and the flow of gas needs to be regulated very closely. Also, the setup is more expensive as we need two tanks. The use of just one tank in Oxy-Acetylene process makes it much less expensive and easier to carry and store. The torch and the hose are simple to use. It is ideal for smaller diameter pipes while still offering the ability to be effective on the larger dimensions. In this process, the heat required for welding is obtained in the form of a flame generated from combustion of acetylene with air. The acetylene gas is stored in a cylinder and is made to flow into the welding torch through pressure regulator and a hose. As acetylene flows through the torch, it draws an appropriate amount of air from the atmosphere to obtain oxygen necessary for combustion. Thus, a clean, hot and smokeless flame is produced. Gas cutting is the most frequently employed thermal cutting process used for low carbon and low alloy steel plates and is often referred as flame cutting. Gas cutting can be used to cut steel up to 2 meters thickness. Gas cutting is a process of cutting metals utilizing a flame generated by the combustion of fuel and oxygen. Oxy-fuel gas cutting process involves preheating a small zone from where the cut has to be started. Compressed oxygen is then made to impinge upon the hot metal, resulting in very high rate of oxidation, which is often accompanied by evolution of heat due to exothermic nature of reaction. Many fuel gases like acetylene, propylene and propane are used in gas cutting process. Acetylene gas is most commonly used as it produces the highest flame temperature of around 3160 degrees Celsius, and thus the process is commonly known as Oxy-Acetylene cutting process. The torch employed for Oxy-Acetylene cutting process is as shown in the figure. The torch will have a mixing chamber where oxygen and acetylene are combined. The torch consists of a nozzle that consists of a central hole surrounded by small concentric holes. The pre-mixed oxy-acetylene gas is made to flow through the small concentric holes, and compressed oxygen is made to flow through the central hole by pressing a lever on the torch handle. Let us now understand the oxy-acetylene cutting operation. Ignite the torch by opening the acetylene valve. A smoke is produced because of burning of acetylene. Gradually increasing the acetylene gas reduces the smoke. Later, switch on the oxygen valve so that the oxygen is combined with the acetylene, thereby producing a neutral flame as shown in this figure. This neutral flame is used to preheat the materials. The neutral flame thus produced is made to impinge on the work metal through the concentric holes surrounding a central hole. This neutral flame is used to preheat the metal. Once preheating of the metal takes place, a highly compressed oxygen is made to impinge the hot metal through the central hole. This results in oxidation accompanied with a large amount of heat, due to which the material gets cut. When the workpiece is cut through a thermal cutting process, the width of the cut is referred as kerf, which depends on the oxygen hole size in the nozzle tip, the flow rate of oxygen through the central hole, and the flow rate of preheating gases. Also, the kerf depends on the speed of cutting and the nature of material being cut. During oxy-acetylene cutting process, the following reactions takes place while cutting ferrous materials. Among these reactions, mainly the third reaction takes place with a release of large amount of heat. The second reaction occurs to some extent in cutting heavier sections. Thus, the gas cutting process offers many advantages over the mechanical cutting methods. This process can cut any desired length and shape. The process can cut metals of thickness ranging from 0.5 mm to 250 mm. There are certain disadvantages in using gas cutting process. This process is limited only for cutting carbon steels. As compared to mechanical cutting, dimensional tolerance of this process is little poor. The workplace needs to have adequate ventilation, and the quality of the process purely depends on the cutting speed. Powder cutting is an oxygen cutting process in which a suitable metal powder such as iron powder or mixture of iron and aluminum powder is injected into an oxygen gas stream to assist the cutting action. The powder cutting process is used to cut materials such as stainless steel, cast iron and non-ferrous metals and alloys that cannot be easily cut by oxy-acetylene process. Let us understand the process in detail. There are certain drawbacks during gas cutting using oxy-acetylene cutting process. While cutting stainless steels, the stainless steels react with oxygen to produce oxides, which further prevent the cutting action by this oxygen. Other metals such as cast iron and few non-ferrous metals either burn with less heat or they tend to cool the cutting zone itself. So, to avoid such difficulties, a finely divided iron-rich powder is fed into the cutting zone. The combustion of iron powder increases the reaction temperature. The equipment used for powder cutting process is similar to the equipment used in case of Oxy-Acetylene gas cutting process. The equipment consists of the following: oxygen and acetylene cylinders with a separate hose and regulators, a hopper with a control valve for automatic supply of iron powder, and a cutting torch. Initially, the oxygen and acetylene gas is made to flow in suitable proportions and is ignited at the torch tip to preheat the workpiece metal. A fine particles of iron powder from the hopper is injected into the cutting flame through the torch tip. The powder is preheated as it passes through the preheated flames. The iron particles are rapidly oxidized, resulting in increase of heat on the work metal surface. As a result of the intense heat, the oxides that form on the metal surface are melted and removed from the cutting area, thus making ease of cutting action. This powder cutting process offers many advantages compared to Oxy-Acetylene cutting process. The process is suitable to cut materials that have high affinity for oxygen at the cutting temperature. This process results in high burning temperature. But during this process, the environment is polluted due to the amount of smoke generated. Thank you, my dear friends, for being here and watching this video. We will meet in the next session with few more concepts that will be very much interesting to you in this subject. Thank you. Have a nice day.